So friends, welcome back to my channel CSNet Lectures. So in this session, we are going to discuss about the applications of BFS and DFS and its differences. That is few points of differences which will be very useful for you in the examination point of view, both if it is theoretical or in the case of MCQ questions. Okay friends, so BFS and DFS applications I have listed out. Okay, so breadth first search and depth first search. So it is used, first I will just give you the explanation or applications of BFS and then I will go for DFS. Okay, so BFS is used to find these different types of options. So it is used to find the spanning tree, that is a minimum spanning tree, that is a cost for traveling from one source to destination. That is minimum amount of cost is nothing but minimum weight, which we are going to discuss it in future under weighted graph. Okay, so the minimum cost which I need to travel from one source to destination, so that we are going to use it in spanning tree. So for this BFS is really very useful. So next is, it is used to find the connected component in DAG. So DAG stands for directed acyclic graph. Okay, it stands for directed acyclic graph. So directed means the path will be directly mentioned. That is, based on that path only I must have to travel. I cannot go in this reverse direction. That is, if it is being given like this, I must have to move only from here to here. I cannot move from here to here. So that is a path which we are going to discuss it in the future, friends. Okay, so to find the connected component, what is called connected? So connected is nothing but there must be at least a single direction or single connection that is being present between the source and destination. So that is called as a connected component. So that we are going to find it by using this BFS. So next is, we are going to find whether a graph contains bipartiteness. So this is one type of a graph which we are going to discuss it. So to find whether there is a bipartiteness occur, that is, it is nothing but sets. We are going to construct sets, and after constructing sets, that is after partitioning the vertex into vertices into two, we are going to link by using different types of edges by following certain rules. So that is called as a bipartite graph. In order to create that bipartite graph, this BFS is really very useful. So next is to find the diameter of the tree. That is, diameter is nothing but the height of a tree. We can use this BFS for finding it. So this BFS is used for implementing single source shortest path finding for DAG, that is for directed acyclic graph. So it is nothing but we are going to find the shortest distance to travel from one source to destination among multiple distance that is being present. We are going to find the shortest distance. So for these applications, we are using this BFS. So next we will go for DFS. So DFS is depth first search. So it has discovery timing and finishing timing. So it is going to tell you what is the time that is used for discovery and what is the time used for finishing. So first you must have to know what is called as a discovery time. Okay, so if I am standing in one location, so I must have to move to the next place. Okay, so if I want to find a new place, what is the time I need to move to that new place? Okay, so that is called as a discovery time. So what is called as a finishing time? So finishing time is nothing but I must have to find my previous, that is I must have to find my previous place. Okay, so I have reached this location. Okay, so from this location, what time it took, okay, to move to this location, that is I want to calculate my reverse timing. That is called finishing time. So the time taken for me to backtrack from my current location, to backtrack for my previous node. So that is called as finishing time. So next, it is also used for finding the spanning tree. So all these things is nothing but for finding. So same thing, it is used for implementing, finding the spanning tree. It is used for finding the strongly connected component for directed graph. So DG stands for directed graph, and I must have to find whether there is a cycle present or not for this directed graph. What is called as a cycle? Starting from the node and I'm going to finish it in the same node. Okay, so that is called as a cycle. So I want to find whether there is a cycle is present or not for this directed graph by using this depth first search. So next I can use this DFS for implementing topological order. So topological order is nothing but it is a sorting technique. Okay friends, so these are all different applications which we are going to use it in BFS and DFS. So now we are going to see its differences. Okay. So friends, these are all the important differences between BFS and DFS. Okay, so just make a note of it. It is very useful for you, right? So BFS is mostly used in undirected graph and DFS is mostly used in directed graph. So BFS implementation is done using queue data structure and DFS implementation is using stack data structure. So friends, about all these things I have discussed in the previous videos, please watch it. It will be very useful for you, right? So now, the another name for BFS is layer order traversal or level order traversal. Another name for BFS is layer or level order traversal. So DFS is used for dense traversal. So meaning is we are going to travel level by level for inserting the elements. So here we are moving in depth, in deeper for inserting the elements. So that is the difference. So next, in BFS we are attaching all the adjacency vertices at a stretch, right? So in BFS we will be attaching all the adjacency vertices and then only we will be moving for the next vertex. But here we attach only any one of the vertex. Very important. So BFS is having finishing time and discovery time for inclusion. But here in BFS we are not having any type of discovery or finishing time. That is, we are not going to perform these two functions here. Okay friends, so this is a very important difference. So make a note of it. It's very useful if it is a theoretical question or if it is asked in MCQ. Okay friends, so in the next class we will meet with another important topic of graph. Bye and thank you.